Okay, so the plan is for the first maybe 2 or 3 sessions, we will go over some of the basics, right? Fundamentals. I'd put a message on the group. Not sure if you guys had a chance. Suhani, did you go through that? My messages from last night. All of you went through. Aditya, you did as well. Okay, so for the first few sessions, we'll spend covering all the basics, and then as we do like specific targeted papers, targeted set of questions on each of these topics, these concepts will become clearer more. Okay, all right. Sanvi, are you able to hear better now? Are you on? If you can turn on your video, please. Okay, let me just share screen meanwhile. Okay, are you able to see this? AMC10, it's written here. Okay, at any time, if anything, if you have any question, please unmute and just ask. Or along the way, I'll also be asking some of you to respond. Whenever I feel like there's something not very clear, I'll prompt one of you guys to clarify or whatever, right? So let's do that. Let's keep it interactive. Okay, so there are like 5 broad topics, right? So there's algebra, there is number theory. So there's a lot of overlap between algebra and number theory. Largely, you can think of number theory as dealing with integers, whereas algebra is not necessarily integers. It could be non-integers as well. And then there's statistics and probability, which is the third main part. And then there's combinatorics, which includes permutations, combinations. Yeah, you can arguably say that probability also comes under that topic. And then you have geometry. And when I say geometry, I mean just plain geometry, coordinate geometry, mensuration, like 2D and 3D, all of that stuff. Okay. And then there's some general concepts, like, for example, symmetry is like all pervasive. In all of these, you would use symmetry arguments. And then there's some basic sense checking or sanity checking one can do and clearly eliminate some of the wrong choices. So suppose you're stuck between like 2 choices. Finally, let's say there are 5 choices and then you're very sure that 3 are wrong. Then to do that, to get to that step of eliminating 3, you can use some basic sanity checking and dimensional consistency, all that. So we'll talk along the way how to approach those. Okay, so let's start with algebra. So I'll try to follow the order that I've mentioned in the snippet that I sent yesterday, but I don't want to also bore, so I'll switch gears. I won't necessarily do all algebra. I'll do some algebra and then I'll change to some other topic. Okay, so let me just paste here. Much bigger than I intended. Okay. All right, able to see this, right? So classification. So what do I mean by classification? So we need to understand the difference between what real numbers are, complex numbers are, rational numbers, integers, whole numbers, natural numbers, all of that, right? So broadly, we have complex numbers. I mean, this is not needed, but just for understanding, right, what complex numbers are. So complex numbers would include things like square root of -1, right? So imaginary numbers, also called as imaginary numbers. Imaginary numbers, right? So the most fundamental unit of the complex number is square root of -1. So which is represented with the letter I. So we cannot do square root of -1, but in an artificial imaginary world, suppose you're able to do square root of -1, that is given a letter called I. Okay, so we can think of numbers like 3 plus 7i. So a number could have a combination of some real part and an imaginary part. So this real part is 3 and the imaginary part is 7i. Okay, that's all I'm going to say about complex numbers, because complex numbers is not there for AMC10. It'll come in handy later for AMC12, and regular school stuff for 11th and 12th also requires complex numbers. But you should, at this point, you should just be aware that there's something called complex numbers. Now, so from this complex numbers, the real numbers is a subset of that. Just 1 second. There's a bit of a noise in my house here. 1 second. Okay, so real numbers is one portion of complex numbers. So how do you think real numbers is one portion of complex numbers? So you can think of two parts, right? So the 7 plus 3 plus 7i that I split. So 3 is the real part and 7i is the imaginary part, right? So the complex number 3 plus 7i has two parts, the real part and the imaginary part. So we are going to focus on the real part and everything to do with the real numbers. Okay, so with that, let me erase all of this complex number business. So we'll start with real, since we are concerned with the real numbers. Okay, so real numbers are those numbers which can be represented on the number line. So if I have a number line like this on the x-axis, or there's only one axis, any point on this number line is a real number. Any point. So for example, let's say √2 is a number. Okay, pi is a number. Okay, and then the number 1 is a number. Like negative 32.8 is a number. So all of these count as real numbers. Okay, anything that you can spot on the number line and mark, that's a real number. And of course, along the way, there will be zero somewhere. I've not drawn it to scale, but that's real numbers. Now, real numbers is represented using the letter capital R. Okay, so the first division that comes out of real numbers is rational numbers. Okay, so rational numbers is denoted using the letter Q. A rational number is what? Anything that can be represented as a fraction, right? Very simply, anything that can be represented as a fraction is a rational number. But when you say fraction, what is a fraction? A fraction is a ratio of two integers. So I can have 3 by 7, right? I can also have minus 18 by 243. So I can also have the number 5, because 5 after all is 5 upon 1, even though I don't put the divide by 1. So that's still a rational number. So anything which is a fraction, which is a ratio of two integers, is a rational number. And of course, the denominator cannot be 0. So I cannot have 0 in the denominator because you cannot divide by 0, right? So a rational number is this. So this is the fractional representation of a rational number. If you look at it from the decimal angle, so if you look at the decimal angle, then a rational number will be something where it will terminate, for example, 0.529. That's a rational number. Or it can repeat with a certain pattern. 3, 4, 7, 3, 4, 7, 3, 4, 7. Okay, so and so on till infinity. That's also a rational number, because it turns out that this can be represented back as a fraction. Okay, so how do we do that? So for example, let's say this is my number 0.347, 0.347, 0.347. Suppose I want to represent it as a fraction. This, of course, is easy. So 0.529 is just 529 by 1000. No problem there at all. But suppose x is 0.347347, then the first thing I can do is I can multiply by 1000. So that I can get 347.347. Sorry, guys, there's a bit of disturbance again in my house. 1 second. Okay, so 1000x is 347.347. So this goes on till infinity. Since this goes on till infinity, I can subtract. I can subtract 1000x minus 1x. You would have seen this trick. Some of you may have, some of you may not have, but here you go, right? So anything that follows the decimal anyway cancels because it goes till infinity. So what we have is just 347. And therefore, we can write back x as 347 by 999, which is exactly what we want, right? As long as it's represented as a fraction, it qualifies for a rational number, right? Now, another thing is the pattern does not have to start right from 0 point itself. So for example, I can have a number like 2.87656565. So the pattern is not starting until this 6. So it starts with 2.87 and then the pattern starts. Even then, we can use this trick of cancelling off the repeating decimals. How do we do it? So first we'll multiply till we start to get the repeating portion right after the decimal. So I'm multiplying by 100 so that the 287, the 0.87 comes to the left of the decimal. So it's 287.65656565, so on. Now I'll do the same trick, right? So I'll multiply by a further whatever to make sure the 65 repeats again. In this case, I need a further 100. So I'll multiply it by a further 100. So become 10,000x. So equals to 287.65.656565. And now I can use the same trick. So I'm not going to completely do it, but I can do the subtraction, right? 9,900x equal to the subtraction of 28765 minus 287, because the 0.65 bar, right? So this is also written as 0.65 bar. So 287. Whatever repeats, you put a bar on top of it. That stands for that pattern repeats after this. Okay, so the pattern is going to get cancelled. So whatever the subtraction of 28765 minus 287, whatever that blah, blah, blah is, I'm just randomly making up some number. Let's say it's 27634, something, right? I can ultimately get the x to be like this, right? And therefore, it's a rational number because it's the ratio of two integers. Okay, all right. So we've covered rational numbers, and then anything that cannot be written as a fraction, right, is a non-rational number, right? So you have Q, and then anything that's not Q. So let me just make some space here. By the way, all the recording will be sent after the class, so you can go through it. You can take your own notes here, but you can also pay complete attention and then look at the notes later if you follow the recording. Okay, so rational is Q. So anything that's not Q is represented using a dash here, like Q dash, or a Q bar like this. So this stands for complement. You'll see both of these usages. So this stands for complement. Complement means what? The one that's other, it's not this, right? Not rational numbers. Those are irrational numbers. So examples of irrational numbers would be numbers like, a classic example would be √2 or even pi. Okay, so even though we say pi is approximately 3.14, it's not exactly that, right? And if you go for a few more decimals also, you don't see any particular pattern. So it's not a repeating pattern. It's an right? It's non-terminating, which means it does not finish, nor is it repeating. So in terms of decimal representation, a decimal which is neither terminating nor repeating is an irrational number. So √2, however much you try, we won't be able to write it as P by Q. If you're able to write, where P and Q are integers. If you're able to write it, then it's no longer irrational, right? It becomes rational. And we can prove fairly easily. I won't do the proof right now, but we can prove that if you attempt to write P by √2 as P by Q, you will hit some bogus result. So that's called proof by contradiction. So some of the proofs in maths follow this logic called proof by contradiction. So suppose you are supposed to prove √2 is irrational. So you start out by assuming let √2 be rational, right? Let √2 equal to P by Q, right? Where P and Q are integers. And then you follow a series of steps. And then finally you get a result which is meaningless, right? Which does not make sense. And therefore we say our initial assumption must be false. Therefore √2 cannot be written in the form P by Q. Therefore it's irrational. Okay, so that's rational and irrational. Now within rational numbers, obviously we have integers, right? So integers are non-integers. Integers are non-integers. So integers are represented using the letter capital Z. A non-integers is Z bar or Z bar or Z dash, right? Anything that's not integers, right? Or you can just say not Z, that's fine, right? So not integers would be like 3 by 2 is a not integer, right? But it's still rational. Minus 7 by 7, minus 7 by 8 is also rational, but not an integer. And integers, as we know, is whatever, right? Round numbers, -5, 0, 1, 13, all of this. Those are integers. And then, in other words, we can split the integers as 3 parts. The negative numbers, right? This part is called Z minus. And then the number 0 itself, which is sort of unique. And then Z plus. Z plus is positive integers, Z minus is negative integers, and the number 0 itself. The collection of all of these is your set of integers. Now, if we take 0 and the positive integers, that is called the whole numbers. So starting from 0, 0, 1, 2, 3, that's whole numbers. But if we just count just Z plus alone, so if you just look at Z plus, that's the set of natural numbers. So 1, 2, 3, the counting numbers or the natural numbers is just the set of positive integers without 0. So Z plus is same as N. N stands for natural numbers. W is whole numbers. Okay, so again, all of this basic information only. Just wanted to make sure that you guys are aware of this and just quickly recap. Okay, any questions so far? I'll pause here. Arab, all good? Okay, Aditya, all good? Okay, cool. The next one I would say is fractions, percent, ratio, and decimal, right? So nothing much really here. So you guys know that they're all equivalent forms of representing the same thing, right? So for example, if 7 by 8 is a fraction, which can also be represented as 0.875, right? And it can be represented as percentages as 87.5%, right? And you guys should be comfortable solving percentage questions. So for example, suppose what percent of 38 is, let's say 7, right? So any question can be translated into math. So what is X, right? Percent, right? This stands for percent, right? Per is division. So cent is 100. So we divide by 100, X by 100. Off stands for multiplication. So this is multiplication, right? In fact, I'll put dot so that it does not confuse with X. So off is multiplication. 38 is nothing but equality sign. And then you can rearrange and solve for X. So whatever that X is, that's your answer to the what, right? So you can translate any English question to a math representation and solve a percentage question. So I guess you guys should be fairly comfortable with that. And when you say two ratios are equivalent, you say they're proportional, right? So 3:4 is the same ratio as 30:40. So they're equivalent ratios. All right. So fairly basic only. Arithmetic progression and geometric progression. We'll come to that slightly in just a bit, because we did that, I think, in the mock class. I'll just definitely touch on this again, no problem. Okay, rates and speed. Rates and speed, it's not just to do with distance and time, right? So speed is rate of change of anything, right? So it's not just rate of change of distance. It could be rate of change of your flow of water, right? Rate of change of the amount of liquid that's being poured into a container. So and then there you have, in rates and speed, you have concept of proportional and inversely proportional. Proportional and inversely proportional. So proportional, we all understand. Inversely proportional also. So for example, if 10 people can build a house. So this is, let's say, people, and this is, let's say, finish a work, right? So if 10 people can finish a work in 7 days, then how long will it take for 20 people to finish? It'll be half of 7, right? It's inverse, right? More people there are. So this is, I shouldn't say work, they should say the time taken to finish the work, right? So this is time taken to complete the work. So 10 people can do a given quantum of work in 7 days. 20 people can do it in half the time. It's inversely proportional. Okay. Now we can do that. We can extend it to a little bit more complicated questions. So for example, so I'll do this. So for example, suppose, yeah. So let's say 24 people can do. I'll say this is job. Job. Okay, can do let's say 3 jobs. Okay, and then this is hours per day. Okay, so if they're spending 6 hours per day. Okay, and let's say this is number of days. Okay, so let's say 10 days. So the statement reads, 24 people can do 3 jobs working 6 hours a day in 10 days. And then a question could be 18 people can finish 5 jobs working at 8 hours a day in how many days? Right. So for this sort of problem, yeah, there are multiple ways to do it. The standard technique is, what is in question? The number of days is in question, right? We'll analyze number of days with respect to each of the other variables. Okay, so let's compare. So we can put an arrow mark like this, right? So I'll tell you what this arrow signifies. So this is the direction in which you're going to write your fraction. Okay, so but first, let's compare days versus people, right? If there is more people, if everything else is same, we would need fewer days to finish the same problem. So people and days are inversely proportional. So I'll put a down arrow because the days arrow is upwards, the people arrow is downwards because days and people are inversely related. Okay, now let's compare days and jobs, right? So if there are more days, then I can do more job, correct? So they are proportional. The number of days and the amount of job that I can finish are proportional because more number of days, I can finish more job, right? So this is in the same direction. And then if I'm comparing days with hours per day, then if the number of people and the amount of job is kept constant, then if I'm spending more hours per day, I'll need fewer days. If I'm spending less hours per day, I'll need more days. So it's inverse. So that's inverse like this. Does the signage make sense? Suhani, is the signage clear on all 3 of them? Okay. Now, the way we complete it is by putting the fraction. So what is the fraction that we say? We say x upon 10 equals, because the direction of the arrow signifies what's the numerator and what's the denominator, is equal to the product of all of these. So 24 upon, we follow the arrow, 24 upon 18 because it's downward. And here it's 5 upon 3. And the last one is 6 upon 8. We are following the arrow direction everywhere. And then, of course, we can get the 10 to the other side, and that's your answer for x. You can solve for x in one shot, rather than, otherwise it can get, of course, this is a very simple example where there are only 4 of them, but you can imagine a few more dimensions added to the same problem, right? And becomes complicated to look at it one by one. If you want to look at it, attacking it like one by one. So collectively attacking it is better. So this way, we are still doing one by one, but we are keeping all the other parameters as constant and looking just at one at a time. Of course, the one that we are trying to solve is always involved. So the days is what we are trying to solve. So that's a common factor. All the other factors that are going to influence it, we want to assess if it's in the same direction or opposite direction. Okay. So those are speed problems. We'll do again a lot of speed problems as well. Okay. Equalities and inequalities. Okay. So what are we doing here? Equalities. So normal equality problem, you guys should be comfortable anyway, right? So any given 7 minus 3x equal to 5 by 2x plus 14, right? So simple stuff like this. You'll convert all the, you'll bring all the x terms to one side, you'll bring all the numerics to the other side and solve it. So I'm not even going to cover it. So something like this, and you'll solve for, you'll get your minus 7 equal to whatever x. So in this case, let me actually finish this, right? That's 5x plus 6x. So it's 11x by 2. And therefore, x is minus 7 into 2 by 11. So this sort of simple solving, all of us should be comfortable. But suppose we have inequality, then it brings a slight, I wouldn't say difficulty, but you should be careful about dealing with inequality. So for example, if I have minus 2x is greater than minus 28, right? Then a mistake that often happens is just dividing by minus 2 and writing x is greater than 14. No, this is wrong, right? Whenever we multiply or divide both sides of an inequality by a negative number, then the signage will flip, right? So instead, what is right is x is less than 14. right? So whenever we multiply or divide by a negative number, that's exactly what we're doing here, right? We are dividing both sides by -2, right? The signage will flip. So x is less than 14. Okay. And then we have problems like fractions, right? So for example, suppose I have x minus 2 upon x plus 3, right, is less than, I don't know, let's say 3. So how do you solve problems like this? We cannot, so the thing not to do is to cross multiply like this. So to say x plus 3 times 3. Okay. Now, this is something we should not do. Arya, can you take a guess why I cannot do this? What will be the problem if I do this?
I'm not really sure.
Just give it a shot. That'll be a natural thing to do, right, Arya?
Yeah.
Okay.
All
right, Aditya, do you know why? What's wrong in that?
No, sir.
No. Okay. Anyone? Ranveer, what about you?
Wait, I don't know.
Sorry, I didn't follow. What were you saying, Ranveer?
I'm not sure.
You're not sure either. Okay. The problem is when we are multiplying, we are multiplying both sides by x plus 3. That's what we are doing, right? It's exactly the same problem that we just saw. What if x plus 3 is negative, right? We are attempting to solve for x, right? We don't even know whether x is positive or negative. So obviously, accordingly, we don't know whether x plus 3 is positive or negative. If x plus 3 turns out to be positive, then what I've written is fine. But if x plus 3 turns out to be negative, then I'll have to flip the sign, right? I should write it as x minus 2 greater than x plus 3 times 3. But the problem is we don't know the signage of x. So how can we, so at least in this case, when minus 2x greater than minus 28, I clearly knew I am dividing by a negative number. Therefore, I could be confident of flipping the sign. But in the case where I'm multiplying by x plus 3, since I don't know the signage of x plus 3, I can neither flip nor not flip. So this will also be wrong to flip. So I cannot do this, nor can I do this for the same reason. What if it's positive, right? Then why do you have to flip becomes the question. Then how do we solve these kind of questions? We bring everything to one side, meaning we subtract the 3 and bring it to the left side. So let's solve this. So x minus 2 upon x plus 3 minus 3 is less than 0. Okay. And then what have we done here? So x plus 3 is the common denominator here. Maybe I'll just change the question slightly just to illustrate. So I'll change this question to, instead of x minus 2, I'll make it, let's say 5x minus 2. Okay. So I just want to illustrate the concept, that's all. So this becomes 5x minus 2 minus 3 times x plus 3 is less than 0. Okay, so what does this simplify to? I have 5x minus 3x in the numerator, which is 2x. And then I have minus 10 minus 9, is it? Minus 19. Correct me if I'm wrong, guys. No, minus 2 minus 9, minus 11. Am I right? So if I'm doing some mistake, please, guys, I'm just making up problems on the cuff, off the cuff. So I might be doing silly mistakes. So please watch out and correct me. So 5x minus 3x is 2x, minus 2 minus 9 is minus 11. Okay, upon x plus 3 is less than 0. Okay, all right. How is this any better? Now, what we can do from here is something called a sign test. So what is the sign test? I can draw a number line. Okay, and then what are the different values of x that cause each expression, be it numerator or denominator, to become 0? So in the numerator, I have 2x minus 11. So when will 2x minus 11 be 0? When x is 11 by 2. So I'll mark 11 by 2 on the number line somewhere. So this is 11 by 2. Similarly, in the denominator, I have x plus 3. What is it will cause x plus 3 to become 0? Minus 3. So I'll mark minus 3 somewhere on the number line. Again, this is not to scale, does not matter. So I have marked the points on the number line, which will cause some term. In this case, there's only one term in the numerator and one term in the denominator, but you can imagine a more complicated expression where I have 2x minus 5 times x plus 7 upon x minus 3 times x minus 3 upon 8 minus x, right? Suppose it is this. Then the terms would be x equal to 5 by 2. That will cause this to become 0. X equal to minus 7. That will cause this to become 0. X equal to 3. And similarly, x equal to 8. So I'll mark all of these points on the number line. So what I mean is, there could be more expressions in the numerator and denominator. In this example that I'm looking at, back to 2x minus 7 by x plus 3, there's only one term each in the numerator and denominator. So the numbers are minus 3 and 11 by 2. Now, what do? I'll look at, let's start with, so these 2 points are dividing the number line into 3 regions. One to the left of minus 3, one between minus 3 and 11 by 2, and one beyond 11 by 2 to the right. So I'll analyze each part separately. To the left of minus 3, what is, we can take one numerical example. So let's say x is minus 4, right? What is the signage of the numerator? 2 times minus 4 is minus 8. Minus 8 minus 11 is minus 19. It's negative, right? And the denominator is minus 4 plus 3, which is negative as well. So effectively, we have a positive quantity, right? So in this region, the ratio is positive. Now, I do the same thing for the region between minus 3 and 11 by 2. I can pick any convenient number in that. Let's say I pick 0. So it becomes 0 minus 11 upon 0 plus 3, which is negative, right? So all I need is to test if it's positive or negative. That's all. I don't care about the numerical value itself. And anything greater than 11 by 2, let's say 11 by 2 is what, 5.5. Let's say I pick 100. So the numerator is 200 minus 11, which is positive. 200 plus 3 is also positive. The ratio is positive. Generally, you will see that things will alternate. If it starts with plus, it will alternate minus, plus, minus, plus, and so on. I use the word generally because there are cases where it does not do it. Plus remains plus. We'll go over those examples as well. But for now, we understand that the signage test has told us in different regions of the x-axis how the expression is positive or negative. And then now we can answer, what is it that we want? We want the signage to be negative. So the answer is minus 3 less than x less than 11 by 2. So that's the range of x values that's favorable for me for this inequality. Does it make sense? Okay. Okay. And then with inequality, there's also modulus or absolute value. That's important. So when you say, yeah, Arav, go ahead, please. You have a question?
So why did we want it negative?
Because this is what we simplified it to be, right? We simplified it to be 2x minus 7 by x plus 3 should be negative. That was the problem. The given problem wanted it to be less than 0. That's all.
Okay.
Does it make sense? Okay. On the other hand, if the given problem had been, so for example, the given problem had been 5x minus 2 upon x plus 3 is greater than 3, then all of the steps so far would be same. And the very last step, we would say we want the positive regions. We want the positive, we want the regions where the expression is positive. Therefore, we'll say x is less than minus 3 or x is greater than 11 by 2. Does it make sense, Arav?
Yeah.
Okay. So actually, one good that you raised it. So this is and. When I say minus 3 less than x less than 11 by 2, it's sandwiched, right? Between minus 3 and 11 by 2. This is equivalent to writing. So for the given problem, it was equivalent to writing minus 3 better be less than x and x be less than 11 by 2. And we want both these conditions. And the sandwich way of writing is a convenient way where you avoid repeating x twice, right? So it's minus 3 less than x less than, but what it means is actually an and. You want both conditions to be true. Whereas if you want a region which is here or here, as the name itself, as I'm saying the sentence itself, I'm saying it, right? We want it here or here. and therefore the word or and would be meaningless here. For example, if I put x less than -3 and x greater than 11/2, this will be meaningless. How can a number be less than -3 and be greater than 11/2 at the same time? It's not possible. It's like saying there's no value of x which will satisfy this, right? So the word of and versus or should be very clear. When do we use and, when do we use or? Is this clear? Ranveer, are you good on this? When to use and, when to use or? And the difference, subtle difference between the two? Yes, Ranveer? Okay, cool. So sometimes I'm not able to see your faces. If you can just unmute and just say yes, that's also fine. Or you can just put your thumb like you did just now. Okay, cool. Suhani, all good so far? Okay, Veer, you're able to listen along? You're traveling, but you're able to hear everything? Okay, I'm not sure if this Veer is able to unmute and answer. Veer, you're okay? Okay, fine. I think you're still struggling with your connectivity. No problem. Sanvi, all okay? Any questions? Okay. All right. Sorry. Who's that? I'm sorry. I'm hearing some lagged noise. Probably from Veer only. So I'll mute you, Veer. Okay. So let's continue. Let's go to absolute value. So absolute value in principle, it's easy, right? So what is absolute value of -3? It's just 3. And what is the absolute value of 7.2? It's 7.2. So in other words, if I want to define absolute value of x, also known as mod of x. So this is also called mod of x. Absolute value of x. So it's nothing but it's x if x is positive or greater than or equal to 0, and it's negative x if x is negative. In other words, you're saying if it's negative, put a negative sign in front of it and make it positive. That's what absolute value of x is. One second. Now, suppose how do we solve for equality and inequality using absolute value? Suppose I have 2x plus 3 equal to 7, let's say, right? So what it means really is 2x plus 3 can either be 7 or 2x plus 3 can be -7. Either of these solutions would work, right? And then you can separately solve this. So this is easy, right? So x equal to 7 minus 3 by 2, which is 2. Or x is -7 minus 3 by 2, which is -5. Okay. And same thing with inequality as well. So we are okay on equality. So suppose I go for an inequality problem with absolute values. Suppose I have 3x plus, I don't know, 5, right? 3x plus 5 is greater than 7. Okay. So what do you mean by this? So we are saying 3x plus 5 should be numerically more than 7, which means on the positive side, it should be a stronger positive than 7, or on the negative side, it has to be a stronger negative than -7, meaning it must be less than -7. It must be more negative than -7, so that the numerical value of it becomes, by numerical value, I mean the absolute value. So it's a stronger negative than -7 or a stronger positive than +7. This is easy. The stronger positive is easy to visualize. Therefore, it's 3x greater than 2. You'll solve the same way. X is greater than 2 by 3. Again, the word or continues here. So 3x is less than -12. X is less than -4. Here I'm dividing both sides by 3, which is a positive quantity. And therefore, I'm not flipping the sign. If you notice, I'm just keeping the less than equal to, less than as it is. So x greater than 2 by 3 or x less than -4. Okay. And now what happens if I have a combination of absolute value and a non-absolute value? So let's make up our problem. So I have 2x plus 1 is greater than 3x minus 2. Okay. Now, how do we do this problem? Okay. So there are a couple of ways in which you can approach. The easiest way is to break down where 2x plus 1 is positive and where 2x plus 1 is negative. So the point where 2x plus 1 becomes 0 is x equal to minus half. X equal to minus half is what will cause 2x plus 1 to be 0. So we'll break the region into two parts. We'll consider x less than minus half as one region and x greater than minus half as another region. Right? So in the region x less than minus half, 2x plus 1 is what is negative. Because, for example, let's say x is minus 10, which is less than minus half. Clearly, 2x plus 1 is negative. So absolute value of 2x plus 1 becomes negative of that negative quantity. So the problem translates to minus of 2x plus 1. The left-hand side is absolute value of 2x plus 1, which is, we know that 2x plus 1 is negative. Therefore, by putting a negative on top of that or to the left of that, it results in the positive quantity that we are seeking. Sanvi, you're with me? Why I put a negative around the 2x plus 1? And then greater than 3x plus 2. And then we set out to solve and see what we get. Okay, so this is just a simple problem. So minus 2x, if I bring it to this side, it's 5x. And then we have minus 1, and then the 2 goes to this side as minus 2. So minus 3 greater than 5x. So in other words, I can write 5x. It's always better to write the independent variable on the left-hand side, right? It's not like flipping sign. I'm not flipping sign here. All I'm writing is in a different fashion. I'm just bringing 5x to this side. That's all I'm doing, right? 5x is less than minus 3, which means x is less than minus 3 by 5. Now, it's important to interpret this well, right? We are saying as long as x is less than minus half, right? Or rather, for the region x is less than minus half, I'm okay with a solution which is less than minus 3 by 5. Okay, let me repeat. So let's convert to fraction decimals. It's easier. So I'm operating in the region x is less than minus 0.5, and my solution is saying I must get my answer to be less than minus 0.6, right? Which means effectively what wins is x less than minus 0.6, because among all the points which are less than minus 0.5, I'll only honor those values of x which are less than minus 0.6, right? And therefore, I will say in conclusion, by combining this and this together, the effective final on this one is x is less than minus 0.6. Are you guys with me completely? Okay. Suppose my worked out to be a little different. Suppose it came out to be x is less than minus 0.3. Then the final result will be x is less than minus 0.5, because we are operating in the region less than minus 0.5. And you want to see what is the overlap with the region which is less than minus 0.3, right? Minus 0.3. So let's say this is 0. Minus 0.3 is here. And minus 0.5 is here. We are looking at numbers only less than minus 0.5. So the overlap between less than minus 0.3 and less than minus 0.5 is less than minus 0.5. So always look at the overlap region between the initial condition that you have and the final condition that you get. Right? Does it make sense so far? Everyone, Aditya, are you with me completely? Okay. On the other hand, suppose suppose the numbers turn out to be that x is greater than 2. So I solve all of these steps. I get x is less than 2, x is greater than 2. Same thing. I look for overlap between x less than minus 0.5 and x greater than 2. There is no overlap. So x can not simultaneously be less than minus 0.5 and be greater than 2. Therefore, there is no solution as far as the left part of this part is concerned. Right? Again, the numbers could work out that way. So the underlying principle is still the same. You look for overlap or the intersection of the different conditions that we have. All of us understand intersection, right? Intersection is the common region. Okay. Thankfully, in this problem, we didn't have all of this confusion. We got x is less than minus 0.6. And then we said that the intersection is x is less than minus 0.6. Now, let's do the other part. X is greater than minus half. So remember, we have only done one part of the question, right? So if x is greater than minus half, then 2x plus 1 is positive because let's say x is equal to, let's take one number greater than minus half. Let's say 3, 2x plus 1 is positive. So my problem just simply becomes 2x plus 1 without the modulus sign because it's already positive. I don't need to do anything, right? So it becomes 2x. Okay, so let me just bring the 3x to this side. So minus x greater than minus 3. And suppose I divide both sides by minus 1, just to illustrate, I'll have to flip the sign, right? X is less than 3. Right, x is less than 3. Now, what am I saying? In the region x greater than minus half, so minus half is, let's say, somewhere here. In the region x is greater than minus half, I want only those values of x which are less than 3. Let's say 3 happens to be here. I'll only consider this. So the overlap between this and this is minus half less than x less than 3. So ultimately, we have to put both of these together. We will say either it's this or this. X is less than minus 0.6 is also fine. X between minus 0.5 and plus 3 is also fine. So you can see that the narrow region between minus 0.6 and minus 0.5 is not a solution. And we can try that also. So unless I did some silly mistake, let's try and put it, right? So you guys are with me. First of all, you guys are completely with me on this. Any doubts before we check one or two? Oops, where did I lose that? Okay. Okay, so let's check. So what am I going to check? I'm intentionally going to put a number that is not in this region. So minus, if I have to plot this region, minus 0.6 is here. So anything to the left of minus 0.6 is fair. Anything to the right of minus 0.5, but to the left of 3 is also fair. So this is my final overlap region, right? Now, I'm going to intentionally put some number here and see whether the inequality makes sense. It should not make sense unless I've done some silly mistake, right? So let's put a number minus 0.55, right? I'll put x equal to minus 0.55 and see what I get. So if I put x equal to minus 0.55, what happens? The left-hand side is absolute value of minus 1.1 plus 1, right? Which is how much? Which is 0.1, negative 0.1 with absolute value, it's 0.1. Now on the right-hand side, what is it? 3 times, am I right so far? 3 times, okay, looks like there is a mistake because where is the mistake? Minus x greater than minus 3. 3. Okay, because so what am I getting? 3 times x is 3 times minus 0.55, which is minus 1.65. Minus 2 is minus 3.65, right? So indeed, this is true, right? 0.1 indeed is greater than minus 3.65. So we have done some silly mistake. That means that's how you check. I could have done some silly mistake. Is anyone able to see any mistake, guys? Can you spot a mistake? First of all, do you understand what I'm trying to get at? I'm trying to validate my answer, and I'm expecting that a region between minus 0.6 and minus 0.5 should not be a solution, but it turns out to be in the solution. So I'm just checking why it is. Oh, yeah, I understand. The problem somewhere became 3x minus 2, and here I've put 3x plus 2 by mistake, right? I copied it wrong from this step to the step, right? So let's do it properly now and finish it. So just so that, so this is, I'll erase this portion completely because this is wrong, right? So I'm surprised none of you noticed it also. Okay, all right. So let me get everything to one side. So it's minus 5x is greater than minus 2 plus 1, right? So minus 1. Minus 2 plus 1, which is minus 1. Right? And then if I divide both sides by 5 or divide both sides by negative 5, I'll have to flip the sign. So x is less than 1 by 5, which means x is less than 0.2. So this left portion where I'm analyzing if 2x plus 1 is negative. So for this, it's an overlap region between x less than minus 0.5 and x less than 0.2. So the commonality of both is just x is less than minus 0.5. Are you guys with me? The commonality between this and this, the overlap region between x less than minus 0.5 and x less than 0.2 is x less than minus 0.5. Ranveer, are you with me completely? You're not lost, right? No one is lost. If anyone is lost, please call out. Okay. Now, finally, when we combine, what do we get? We get x is less than minus 0.5 or minus 0.5 less than x less than 3, which means there's no minus 0.6 at all anymore. So I'm okay with anything less than minus 0.5. I'm okay with anything between minus 0.5 and 3, but I'm not okay with minus 0.5 itself. So at the point minus 0.5, the inequality does not hold good. But other than that, anything to the left of 3 is good. So let's check. So if you put a number minus 0.5, if I put x equal to minus 0.5, then this becomes 0, right? Is greater than. Okay, all right. We can check it later, guys. So you understand what I'm trying to get at. So I want to move on. But if you do a silly mistake, just catch it sooner than later, right? All right, let's move on. So I wanted to cover equality and inequality. Telescopic cancellation, that's important. So what is telescopic cancellation? Suppose I have 1 by 2 into 3 plus 1 by 3 into 4 plus 1 by 4 into 5. And let's say I go till 1 by 9 into 10. Now, problems like this, obviously, if you start doing it like 1 by 1, then we are not going to head anywhere, right? So it's not going to finish. So there's a easy trick that we can follow. What we do is we'll replace the 1 in the numerator as 3 minus 2. So we'll see what happens. And then we'll replace the 1 in the numerator as 4 minus 3, 5 minus 4, and so on. 10 minus 9 by 9 into 10. Right? So this becomes 3 by 2 into 3. That becomes 1 by 2. 2 by 2 into 3 becomes minus 1 by 3. Okay. And now the first term here, 4 by 3 into 4 becomes 1 by 3. And then 3 by 3 into 4 becomes 1 by 4. Similarly, 1 by 4 minus 1 by 5. Following the same pattern, here it's 1 by 9 minus 1 by 10. Now, you can see that there are a lot of cancellations here. The minus 1 by 3 cancels off with 1 by 3. Minus 1 by 4 cancels off with 1 by 4. The minus 1 by 5 will cancel off with this. And then all the way till the minus 1 by 9 that is sitting to the left will cancel with the 1 by 9 here. So we'll be left only with the two extreme terms, half and 10. And now we have an easy answer. So whatever that is, right? So this is 5 minus 1, which is 4 by 10 or 2 by 5. Okay, so we can simplify this. This trick is called telescopic cancellation. Right. Now, not always will the numbers be like round like this, right? So for example, suppose I have, is this clear, first of all? Arav, you're good on this? Sanvi, you're good? Okay. Now, suppose it's not so direct. Suppose it is 3 by 4 into 8 plus 3 by 5 into 9 plus 3 by 6 into 10. And all the way till infinity. The fraction is getting smaller and smaller. Can you guys try this? So by a similar logic to the above, but can you try it? Let's see what you can do. It's the same similar telescopic cancellation, but thoda extra step you have to do. Okay, so Sanvi, I just saw your message from a few minutes ago that you keep on getting disconnected. Is this still a problem or you're okay now?
That was earlier, my internet.
Okay.
Thank you.
Actually, let me just make it simpler for you. So first, we can still do this, but first, let's make it as 8. We'll keep it continuous. 8 into 12, 12 into 16, 16 into 20, this way, and so on. I'm sorry, let's try this first. Is the handwriting clear? It's 4 into 8, 8 into 12, 12 into 16, 16 into 20, and so on. Aditya, any idea how to approach this?
So I'm still thinking.
Okay. Suhani, how about you? How to do this?
I started doing it. I'm still
Okay.
trying to figure it out.
Okay. Okay, anyone? I'll open it up to anyone who has, even if you have a partial solution, it's fine.
I just tried using the denominator, the same thing you did above, but I multiplied the numerator using FOIL.
Okay. You multiply the numerator using what?
So I put so for example, 3/4 times 8 was 3, 8 minus 4 in brackets for the numerator.
Yeah.
Over
But-
4.
And then an extra 4 here. Is that what you said?
Yes.
Okay. Yes. That's exactly right. So first of all, 3 is common. So let me just start all over again. So the 3 is common. I can take it outside the brackets from everything, right? So now it just becomes 1 by 4 into 8 plus 1 by 8 into 12 plus 1 by 12 into 16 plus 1 by 16 into 20. I'll just write one more term so it's clear. And now the numerator, 1 is not the subtraction of 8 and 4 like it was in the previous question, right? But I can still write it as 8 minus 4 as long as I can compensate it by multiplying by a 4 in the denominator as well. So same thing for every single term, right? So I have 12 minus 8, so which is a 4, but I've divided by 4 here in the denominator. And so on. 16 minus 12 by 12 into 16. And so on, right? So now what do I get? I get the 3 by 4 common outside. And then the same thing, 1 by 4 minus 1 by 8 plus 1 by 8 minus 1 by 12. And then this term becomes, the third term becomes 1 by 12 minus 1 by 16. And then this keeps going on till infinity. It does not end anywhere, unlike the previous problem. So we have a series of cancellations. The very last term might be 1 by infinity, so to speak, right? You cannot write 1 by infinity, but just to imagine, it's practically 0 anyway, right? It's 1 upon a huge quantity, which is 0. So the answer is just 3 by 4 times 1 by 4, which is 3 by 16. So the only prevailing term is 1/4. There is no term at the end because it goes on till infinity. Right? Does it make sense? Arya, are you with me completely on this?
Yeah.
Okay, cool. Okay. Let's see. The next set of topics is floor, ceiling, and round. Okay, so what is this floor function and ceiling function? So rounding function, all of you would have studied, right? So if you have a rounding of, if I'm rounding 7.9, that's 8, right? Whereas if I'm rounding 3.2, that's 3. Okay, that we all understand. Now the floor is, so floor of 7.8 is the integer which is less than or equal to 7.8. So the floor of 7.8 is 7. Right? So which it's represented using this, like you have a floor which is holding 7.8, right? Is 7. Another term that's used for this is called the integer function. Integer of 7.8. The integer part of 7.8 is the integer that's less than or equal to. I have to use the word equal to because if you have floor of 9, that's 9 itself. You don't go to 8 because you're already at an integer. So it's the integer which is less than or equal to the number that you have as an input. So integer of 7.8 or floor of 7.8 is 7. Likewise, okay, by the way, so floor of so this is interesting, right? So what will floor of Ranveer, what will floor of minus 2.3 be?
Would that be -2 or like?
Would that be what? I didn't fully hear you. Would that be what?
-2?
-3, right? Because minus 2.3, you're looking down, you're going further.
Oh yeah.
And then the next integer that you hit would be -3. So
Okay.
floor of minus 2.3 is -3. So you should be careful with negative numbers, right? And the opposite concept is the ceiling. So ceiling is looking up. So ceil of, again, let's say 3.2 would be 4, right? But ceil of an integer, ceil of 5 is just 5 because you're already at an integer. If you're already at an integer, you just keep that integer. If you're not integer, you have to look up till you reach an integer. So by that same logic, let's say Sanvi, what will ceil of minus 99.2 be?
I'm guessing it would just be -99.
Minus 99, correct, exactly, right? So that's floor and ceiling. And then rounding, of course, you guys know. So that's a interesting set of questions with floor and ceiling. So let's see if I'm able to make up some question. All right. Okay. I'm sure there'll be questions, right? So let me not invent something right now. Let's move on and cover the basics first. So that's floor and ceiling. The next is quadratics. So quadratics is very important. So let's take a few minutes to understand quadratics well. So all of us know linear equation. So if I'm solving for 2x minus 7 equal to 0, we know x is 7/2, right? But suppose I have a quadratic like x square minus 7x plus 12 equal to 0, right? So there are like a couple of ways in which we can solve, right? At least 3 ways. One is factorization. Okay. And one is completing the square. Okay. Completing the square. I'll come to what this technique is. The other thing is use the quadratic formula. Okay. All 3 are important to understand, right? So what is factorization? We look for 2 numbers that add up to -7 and multiply to +12. So that we know, right? So the factorization will be, I'll split into -4x minus 3x plus 12 equal to 0. And then I'll combine these two. I'll say x into x minus 4 minus 3 into x minus 4 equal to 0. And therefore, I can write it as x minus 3 times x minus 4 is 0. And then when I have product of several quantities is 0, that means one of them is 0, which means either x is 3 or x is 4. That's how we solve this, right? So that's the factorization. Now, what is completing the square? That's a new thing that you guys learn now, right? So first, we know that p minus q whole square is how much? P square minus 2pq plus q square. Similarly, p plus q whole square would be p square plus 2pq plus q square, right? So we'll use that to our advantage here. So we'll say this is x square, and then instead of 7x, I will read it as 2 times x times what will make it 7 as 7/2, so that the 2 cancels, right? So I've written 7x as 2 times x times 7/2, and then I'll add 7/2 whole square. But I cannot just add it for free. I'll have to add the 7/2 whole square to the right hand side as well. And then the plus 12 that I have just carries along. The plus 12 just carries along. So all I've done is two things. I've replaced the 7x as 2 times x times 7 by 2. And then I've added this quantity 7 by 2 whole square. Now, why did I add 7 by 2 whole square? So that this portion looks like your p square minus 2pq plus your q square. Okay, so except that it's not p, it's x. It's not q, it's 7 by 2. So I have x minus 7 by 2 whole square, hence the name completing the square. We are trying to complete a square. There was no square initially, but I've artificially added some terms and made it look like a square. Equal to what? I can move 12 to the right-hand side. So I have a 49 by 4 on the right-hand side minus 12, which is 49 minus 48 is 1. Right? So I have x minus 7 by 2 whole square is 1 by 4, which means x minus 7 by 2 is plus or minus square root of 1 by 4, which is plus or minus half. Okay, so on that note, it's very important to, so just a side note here. So if I have square root of 25, it is only positive 5, right? The symbol square root stands for the positive root. So square root of 25 is just positive 5. It's wrong to say square root of, so if you write this as plus or minus 5, it's wrong. So this is wrong, this is correct. Okay, so if I have x square equal to 25, that's a different problem. Then you say x equal to plus or minus square root of 25, and therefore x is plus or minus 5. Right? Whereas if I have x equal to square root of 25 as it is, that means x is only the positive 5. So this problem and this problem are different problems. X equal to root 25 is a different problem than x square equal to 25. Okay, right? So in this step, I have x minus 7 by 2 whole square is 1/4. Therefore, x minus 7 by 2 is plus or minus square root of 1/4, which is half. And therefore, I can get the 7 by 2 to this side and say it's 7 by 2 plus or minus 1 by 2. I can combine it this way. I can get one of two answers. 7 plus 1 is 8, therefore it's 4. 7 minus 1 is 6, therefore it's 3. So x is either 4 or 3. We get the same result as what we got by factorization, but by using this completing the square, right? So it's convenient when you cannot factorize something. For example, suppose it is x square minus 10x plus, I don't know, let's say 3 equal to 0. I cannot find two numbers that add up to minus 10 and multiply to plus 3. But I can use this completing the square technique to find the roots. So let's do that once for practice. Let me just create more space here. So I'll use the exact same technique. Okay, so I'll write it as x square minus 2 into x into 5, because that's what makes it 10. I'll add 5 square. Okay, and then I have the plus 3 here. And then I have added the 5 square to the right side as well. So now this is nothing but x minus 5 whole square. Okay, and I can move all the numbers to the right hand side. So it's 25 minus 3, which is 22. Therefore, I can say x minus 5 is plus or minus root 22. And therefore, my x is 5 plus or minus root 22. Right? I could not have factorized this. So this completing the square comes in handy. Okay, now, since we don't want to be doing completing the square every single time, people discovered this, the quadratic formula, which does it for us. So the quadratic formula, you guys remember what the quadratic formula is? Ranveer, do you know what the roots of ax square plus bx plus c equal to 0 is? Are? Ranveer?
Oh, wait, so could you repeat the question?
So if I have ax square plus bx plus c equal to 0, if I have a quadratic equation like this, what are the roots of this quadratic equation? Have you done this?
But what do you mean by the roots? Like,
The values of x, which will make this true. Okay, Sanvi, have you done this? Okay. Anyone has seen this? Arya, you have seen this?
I know the quadratic formula.
Okay,
And
what is the quadratic formula, please?
I think it's x equals to minus b plus minus root b squared minus 4ac all over 2a.
Exactly. That's exactly what I was looking for. And if you guys have not done this, no problem at all. I mean, typically this is done in 10th grade, but some of you might have already covered it, which is why I was asking. So no harm in not knowing, but now is the time to learn this, right? Yeah. So well recapped there, Arya. So it's minus b plus or minus square root of b square minus 4ac whole upon 2a. Now, what is this whole business? So it's giving you a cookie cutter way of solving a quadratic equation. So let's try to apply in this problem, x square minus 10x plus 3, and see what we get. You're with me, Ranveer, so far. So it's a just formulaic approach for solving any quadratic. So in this case, a is 1 because it's x square minus 10x plus 3. b is minus 10. And c is 3. Correct? So let me apply this and see what values for x I get. I should hopefully get the same answer as here. Let's see. X equal to minus b, which is minus of minus 10, which is plus 10, plus or minus square root of, let me calculate this b square minus 4ac separately here. So b square minus 4ac would be minus 10 whole square minus 4 into 1 into 3, which is 100 minus 12, which is 88. So it's 10 plus or minus root 88 whole upon 2 times 1, which is 2. Okay, can I simplify this? Yes, I can. I can write 88 as 22 into 4. So when I write square root of 22 into 4, it's square root of 22 into square root of 4. So square root of 4 can come out as 2. So it's this whole upon 2. So the 2 can cancel off, leaving just 5 plus or minus square root of 22, which exactly matches with what I got here. Does it make sense, guys? Yeah, Arab, you have a question? Go ahead, please.
So for completing the square, can we use the vector form minus b over 2a to find the two x roots?
Yes, you can do that as well. Okay, so I was going to come to that next. Good that you brought it up. But is this clear so far, guys? Sanvi, Suhani, all good? Okay, now we can even try. There's no reason why we should do this only for where it's not factorizable. Where it's factorizable also, we can do it. For example, let's go back to the question that we had that we could easily factorize. X square minus 7x plus 12. You remember we factorized it as x minus 4 and x minus 3 and got the roots as 4 and 3. Let's see whether we get the same answer. So a is 1 here, b is minus 7, and c is 12. So let's calculate the b square minus 4ac. So that's minus 7 whole square minus 4 into 1 into 12, which is 49 minus 48, which is 1. So we have minus b, which is minus of minus 7, plus or minus root of b square minus 4ac, which in this case turns out to be just 1, whole upon 2 times 1, right? So it turns out to be 7 plus or minus 1 by 2, exactly same as what we got, right? So 4 or 3 were the two choices. Okay. Right, so far you're good. Now what Arya was saying, or was it Arav was saying, right? So that's another form of the same quadratic called the vertex form. So what is this vertex form? So first of all, let's understand. Okay, let's start with a different problem. Then I'll set the context for you. So suppose I have x square minus, let's say, let's make up some number 8x plus 12. Okay, now this is an expression. There's a difference between an expression and an equation, right? This is a free floating expression, right? You cannot solve this. By earlier, Ranveer was asking, what do you mean by solve? Solving means finding specific values of x which will make a certain equation come true. For example, this is an equation, and you can solve, meaning we can identify the values of x which will make this true. That's called solving. So we can solve this. It's an equation. So this is an equation. An equation can be solved. Whereas this is an expression. An expression can be factorized. Right? So I can write it as x minus 2 times x minus 6. I could guess that the two factors are minus 2 and minus 6, which add up to minus 8 and multiply to plus 12. Right? Now, it can be factorized. It can be plotted. Right? I can plot x square minus 8x plus 12. Okay. So how will x square minus 8x plus 12 look like? So let me just bring up something called GeoGebra. So it's a very convenient. You guys should also try this. Let me just stop sharing this. Start sharing this. So I'll send you the link for this as well. So you might have to seen this. Suppose I have x square minus, I think it was 8x, right, in my problem, plus 12. Okay, so you could see that it factorized to x minus, are you able to see my screen, guys? GeoGebra, sorry. All of you good? Okay, so it factorized to x minus 2 times x minus 6. Suppose we take that product and set it equal to 0 and solve that, then obviously x is either 2 or x is 6, which is why we are seeing that when x is 2 or when x is 6, the expression itself becomes 0. That becomes the solution. Ranveer, are you with me completely?
Oh, yes, sir.
Right? But x equal to 2 and x equal to 6 are just one of the infinite or two of the infinite points on this entire graph, which is x square minus 8x plus 12. We can plot this graph and see that this shape is called a parabola, right? This upward going parabola, right? Now, an expression can be plotted. Now, the value of x where it takes the lowest value, the turning point, is called the vertex. And that happens exactly halfway between the two roots. The two roots are 2 and 6. The two roots are 2 and 6. The vertex, which will be exactly halfway between the two, which is why it's at 4. Okay, so that's what Arav was referring to. I can use the vertex form of writing the same expression. So how can I write that? I'll just go back to the original share. I can write it as you're able to see this thing, right? My notebook, right? X minus 2 times x minus 6. I can also write it as, so the same expression. Let me call this expression a name called y. So y equal to x square minus 8x plus 12, also known as a function. So it's a function that relates x and y. Think of x as an independent variable and y is a dependent variable. Depending on different values of x, it takes different values of y. Specifically, it takes a value 0 when x equal to 2 or x equal to 6. Okay, but for other values, it takes non-zero values. Now, I can write this as x minus 4 whole square plus something, right? The 4 is nothing but the average of the 2 and 6. We saw the 2 and 6 were the roots. If you set it equal to 0, roots or solutions, right? When you solve, you get roots or solutions. Okay, so exactly halfway between the two roots is the vertex. The x coordinate of the vertex happens to be the average of the two roots, which is 4. Now, what he's telling is I can write this as x minus 4 whole square, but plus something, of course. So that comes from completing the square. So this is, I can write this as x square. Okay, I'll write here x square minus 2 into x into 4, right? X square minus 2 into x into 4 plus 4 square. But notice that what I have does not have a right-hand side. So I'll erase the equation, right? The equation is where you have the right-hand side, so they're equal to 0. But right now it's a function or an expression. There's no right-hand side to it. So I cannot just add 4 square. I'll subtract 4 square here. And then the plus 12, I have it as it is. So all I've done is the 4 square has not been added to the right-hand side because there is no right-hand side. You've just added and subtracted 4 square. That's all. So this guy is x minus 4 whole square. And this guy is 12 minus 16, which is minus 4. Okay, so this entire expression right now is x minus 4 whole square minus 4. Okay, I wish I could have come up with different numbers, but this both coincidentally happen to be the same number, need not be. So this is called the vertex form. Why is it called the vertex form? So this is called the vertex form, and this is called the factorized form. Why it's called the factorized form? That's very clear, because you have two factors, x minus 2, x minus 6. And to solve it, x either has to be 2 or x is equal to 6. That's easy to see. This is called the vertex form because this gives you what the vertex coordinates are. So how do I get that? If I look at x minus 4 whole square, it's always a non-negative quantity, correct? The bare minimum it will take will be 0. X minus 4 whole square will become 0 when x equal to 4. For all other values of x, be it more than 4 or less than 4, it's going to be a positive quantity. So the minimum point, the minimum value of y will happen when x equal to 4. Correct? That's when 4 minus 4 whole square becomes 0. And that minimum value is how much? 0 minus 4, which is minus 4. Again, no connection between this 4 and minus 4. In this case, it just so happened the two numbers turn out to be 4 and negative 4. But in general, it could be two random numbers. Right. So the vertex itself is 4 comma minus 4, which is why, if you recall, let me go back to the GeoGebra again, the share screen. The turning point that you see here is 4 comma minus 4. By completing the square, we got that 4 comma minus 4. Are you guys completely with me on this? Sanvi, does it make sense? Okay. Good. Okay. Back to this. Now, so in this case it is it's 4 and minus 4. But is there a general expression to find the vertex? Yes, there is. So the two roots were, just to recap, minus b plus or minus root of the b square minus 4ac. The b square minus 4ac is just given a different name so that we don't have to keep writing it every time. It's called discriminant. It's written with capital D, discriminant. So the two roots, if you set it equal to 0, are this: minus b plus or minus root d whole upon 2a. Okay, as we just saw, right? That's those are the roots of the quadratic equation. What is this? These are the roots of the quadratic equation ax square plus bx plus c equal to 0. Those are the solutions, or roots mean the same thing, right? Now, what did we see? We saw that the vertex coordinate is exactly halfway between the two roots. So the two roots being minus b plus root d by 2a and minus b minus root d by 2a. So exactly halfway between these would be the average of these two, right? If I take the average of these two, I'll see what I get. The root d and root d gets cancelled. So I have minus 2b over 2a times this 2. So the 2 gets cancelled. So minus b over 2a. So the x coordinate of the vertex is minus b by 2a. Right? Let's verify if it holds good here. So for this problem, if I apply minus b by 2a, let's see what do I get. So as I said, a is 1, b is minus 8, and c is 12. If I do minus b by 2a, I get minus of minus 8 by 2 into 1, which is 4. And sure enough, the x coordinate of the vertex was 4. And the y coordinate of the vertex is got by substituting this 4 in the expression itself. If x is 4, what is y? I'll just go here and substitute. What do I get? I get 4 square minus 8 into 4 plus 12. So 16 minus 32, which is minus 16, plus 12, which is minus 4, which matches with the minus 4 that we got here. So everything is the same thing. In different ways, you're looking at the same thing, right? You arrive at the vertex by taking the average of the two roots, and then you substitute that x value, and then you get the y value of the vertex, which will be the lowest point on the parabola. Suhani, all this is okay? Too heavy or okay? All good. Okay. Aditya, you've been quiet as well. All good. Okay. Now, not always is the parabola upward going. So it's upward going because the coefficient of x square is positive. So upward going parabola is when the coefficient of x square is positive. Now, suppose I have a parabola which is minus 2x square plus 7x minus 13. Then you'll see this parabola looks something like this. Okay, but other than that, all the rules apply the same. Finding the roots are still same, minus b plus or minus root d whole by 2a. The coordinates of the vertex is still same, minus b by 2a, right? All of that is remain same, but the shape of the parabola is downward facing. That's the only thing to remember. Okay, so that's quadratic. Let's see what else I wanted to touch on today before we wrap. Yeah, we covered functions briefly, right? Like when we write an expression, it's just a free floating expression. X square minus 7x plus 12 is an expression. Once you assign y equal to something, it becomes a function. So the y is called the dependent variable. It depends on the specific value of x, right? So a function relates two variables. It could relate multiple variables also, but in the simplest form, you have an independent variable x and a dependent variable y, which is a function of x, which is why the name function, right? Depending on different values of x, the y value changes. Okay, before we wrap, maybe we'll just do a quick recap of the normal simple expressions that we are supposed to know, right? So a plus b whole square, a minus b whole square, all of us know, right? So I'm not going to repeat it. So in terms of factorization, a plus b whole cubed is also important. So which is a cubed plus 3a square b plus 3ab square plus b cubed. Okay, so if you guys have not done this, you should know this. And a minus b whole cubed will also be very similar. It will alternate between positive and negative. So we'll start with plus, go to minus, go to plus, go to minus. So these two are important as well. And then, of course, if I have a square minus b square, that's a plus b times a minus b. And then if I have a cubed minus b cubed. Okay, by the way, a square plus b square cannot be factorized. There's no expression that will say it's a product of this and this, right? But a cube plus b cube there is, and a cube minus b cube also there is, right? So you should remember this in case you're not aware already. So this is a minus b times a square plus ab plus b square. It's not 2ab, it's just ab. And here it is a plus b times a square minus ab plus b square. It's a little counterintuitive, but a cube minus b cube has a minus here and a plus here, and it's the reverse. It has plus here and a minus here. Okay, so these factorizations you should know. Yeah, I think that covers most of what we need to know in algebra. So next class we'll do a bit of number theory in terms of squares, cubes, primes, composites, divisibility rules, right? Pythagorean triplets, right? So for the next 2 more classes, we'll cover all the basics, and then we'll jump into topical problems. Okay, I'll pause here. Any questions at all from whatever we discussed today? Is this pace good, or is it slow, or is it fast? If you guys want to reply to me offline, that's also fine. Or if you want to call it out here, that's also fine. What do you think, Ranveer? Is the space good?
Oh, yes, sir. Yes.
Okay, not too fast, not too slow, right? Sanvi, you're okay? Aditya? Cool. All right, I'll see you next Saturday. I'll send you the recording of this. Although this is all trivial information, just make sure you're solid on this, because this is the underlying foundation for things to come. So don't trivialize it. Just make sure, especially the quadratics part, which was very new to you. So just definitely brush up on that. Okay, Suhani, all good? I'll see you next week.
Yeah.
Okay, bye then. See you guys.
Thank you. Bye.
Sure. Bye.
Thank you.